Now let's look at an improper integral where we're headed to negative infinity. So let's look at this example here from negative infinity up to 0 of e to the 2x. So let's remind ourselves of that definition we had. What we really mean by this is that you're going to start at some a, integrate up to 0, and then we're going to see what happens as a slides out to negative infinity there. So first thing we always want to do is rewrite that as a proper integral. So we mean the limit as a goes to negative infinity, the integral from a up to 0 of e to the 2x dx. So this symbolically is saying that let's just go to some finite amount and then let's see what happens as we go farther out. So e to the 2x, that's technically a linear u sub, but remember our shortcut, we can just divide by the coefficient there on x. So that's 1/2 e to the 2x. So we're looking at the limit as a approaches negative infinity of 1/2 e to the 2x from a up to 0. And so we'll evaluate our integration limits there. So we're looking limit as a approaches negative infinity. And remember that limit doesn't really affect anything until we're done with the integration. So that's 1/2 e to the 0, which is e to the 0 is 1. So that's just going to be 1/2 minus 1/2 e to the 2a. So again, let's remind ourselves, what is that just telling us at this stage? That what we have here so far is 1/2 minus 1/2 e to the 2a. And then what happens as a goes to negative infinity? Well, then you're taking e to larger and larger negative numbers, right? 2 times a negative number is a negative number, and it's just getting more and more negative. So that's heading to 0. So we just end up with 1/2. Now, I haven't introduced this terminology yet, but one of two things can happen when we're doing an improper integral. This limit may not exist, right? We know from limits that limits don't always exist. It could be that as you slide farther and farther out, the area under the curve, in the positive case, or just in general, the integral is not approaching any value. So if the limit exists, we say this integral converges. So this integral converges to 1/2. If this limit didn't exist, we would say that that integral diverges. If the limit exists, we say the integral converges. If not, we say it diverges. So what we have here is a convergent integral. It's converging to 1/2. The value, as we take that out farther and farther, is converging on the value of 1/2. So it's a convergent integral.